you a couple of information regarding the test one. One with the rehearsals on the test itself. The other one, all the particulars of the test, what you need to do before on doing the test and also after the test. So please follow the instruction, and this is not this is not new. Yeah, I think you've been doing this one so many time in your test within 3 or 4 semesters, I believe. Yeah. Okay, before we start the new lecture, the second information I would like to share with you is I also provide you the, the notes this morning, Alhamdulillah, with the new topics on the balancing. But this time around, we're going to look for balancing on the engine. We call it as reciprocating balancing set. Okay, I would like to stop sharing this one, then I'm going to share with you blank blank hold on blank what blank template now, blank slide, so that I can write something on it regarding the test. Yeah. Okay, do you have the blank slide with you? I need to share first. I would like to share here. Share. I would like to share. Where are you? I would like to share. Yeah. Yes, this one. Okay. This is the one. Uh, okay. For test one, I think everybody aware about the dates and also time on test one. So for test one, we 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 meet the agreement on the test one on which topic will be included. Yeah. Among the lecturers. So we are going to I'm going to share with you a couple of things. Yeah? So for test one, I think other section already discussed about this one. For test one, you've been given inshallah three equation. Yeah. So it's a compounds some equation. So there's no option within one and one and hour. So if you found that you have two equation or this one, so it simply means that one equation carry 30 minutes. Okay, so I already prepare for the equation. Yeah, I do find them when I give the equation to lecturers in the new lecture typically, so they can uh, answer the equation within 25 minutes with correct answer, of course. So if you so if student is if sorry, it's not 50, 25 minutes, 15 minutes. So if the lecturer can answer 15 minutes with all calculation, so you can answer, of course, 30 minutes with correct one. Of course, you want to get the correct one, you have to study. So now the topic will be topics. One, obviously, we are studying about gear system. And right from the beginning, we've been studying hoist. Then we go for the vehicle dynamics. And finally, you have this one, number 3 is what they call it is epicyclic gear. Yeah, epicyclic gear. And you done this one in your tutorial, so that's why I purposely give you so many problem typically on the assignment. Just you can do your practice. You done this one, you got the result, you got solution with you. You can compile and you can run through again. So typically this one, yeah, this one is due to the gear system. So you have this one equation, one equation, one equation. But if you look at this one, so this one is the easiest one, vehicle dynamics. And then so equation topics in the gear system could be coming from this one, hoist, and epicyclic. So now you have two equations. Correct? The next one we study is balancing. The next one is a gyroscopic. Gyroscopics couple. Here you have how many special topic you have? You have a shaft and rotor. You have this one is aircraft. This one is you have vessel. This one you have um, land vehicles. So this one will be your next equation, which you have one equations. So don't worry if you're so many things one, isn't it? But you know that the principle will be number one. What the principle is the m equal to I dot omega cross precision. Or some book they write the m equal to I precision cross omega, same thing. Okay. Number two, the procedure will be what? Is always what? Start with gyroscopic vector diagram. Correct. This one you can calculate and you know well that all the parameter. So this one from here, then you know that you have to apply one thumb rule. You have to apply one right hand Fleming rule. Correct. What is your concern? Your concern is to define this one and precision. Always start with this one with thumb rule. This one also with thumb rule. The next one M here, then only you have to use the right hand Fleming. Okay, because we are doing this one for the sake of the effect, so look for reactive if on bearing. What else? Bolt and nut. What else? Bracket. Look for reactive, meaning that is the effects, isn't is the effect. Okay, so that's about it. If you're talking about, for example, yeah, for remember this one for rotor and shaft, for what else? Aircraft, for uh, vessels or ship. Yeah, this one look for the spin velocity. Spin velocity is at what? Rotor, propeller, propeller. What else? Fan. What else? Turbine, turbine rotor. Yeah, isn't it? Spin velocity is always with that, except for what? Land vehicle. Because when talking land vehicle, the spin is on where? Is on what? Is on wheel. Or sometimes it is not wheel, it also can be rotor. Why? Because this one why land vehicle? Because this one the wheel or rotor touches solid surface. This one you don't have a solid surface, correct? Aircraft is always in the air. The rotor is also in the air, isn't it? It's supported by bearings and so forth. Supported by shaft, so on and so forth. This one on where? The vessel is on water. So when the wheel is supported by bearing, when the wheel is supported or run to the solid surface, so you know that the spinning will be on wheel. Okay, that's about it. So that is simple. So study about vessel. The last one is this one most lecturer say to me that this one not in But even though it is not included, you have to understand that even row 2, yeah, when the row 2 will be on the solid surface, is always you have the normal what? Normal forces. Okay, that's about it. It's not very difficult. Trust me. What you've been studying in class, inshallah, will be in your test. Of course, there will be no there will be no exact equation in your test and also in class or tutorial. There might be some other problem, but related what we have studied in class. Will that help you? Another question? Another question? No, thank you. Okay, now I also they are also stop and one of the topics, if I can recall back, we've been doing this one, but suddenly it is only halfway of the solution, which is if I can go back to the notes here, we completed on this one. Uh, okay, let me at least for one page, the rest you can follow, or the rest you can do on your own and make this problem number one, this one to be your reference to do the next one. And because if you go problem by problem, you found that it is not very difficult, or it is not very different from what you have in notes and also in the solution for problem number one. But at the end of the day, you need to understand the problems, okay, before you start doing anything. Okay, let's start this one. Yeah, I'm going to change this one position. So you have this one. We already completed, and if I can recall back, we already completed and this one, and we already also completed at the here. The two one is one completed. So we're going to move at the total maximum force, and I want your help because I forgot about all the numbers that we are done yes the day before yesterday. Okay, if I can do this one, number 3, what you have is to define what the total maximum force on bearing A and B. Now it's total maximum force. We already come to agreement that this total maximum force is, dynamic force. Remember this one, dynamic force follow static force. Then add up together. Okay, if I'm not mistaken, yeah, the last thing that we study on, can anyone tell me what is the FA? What is the FA? What is the FA? Bearing, yeah, this one on bearing. What is the FA? What is the value for FA? Can anyone? And what would be the angle, the position? It's easy for me to start. Anyone? What is the FA earlier? Can you look back your solution class? What do you have for FA and what do you have for FB? So give me theta A and also theta B. Then we'll start with that. Anyone? So if you can't help me this one, I also uh, can proceed because I don't have any numbers or don't have any answer here. So what do you have for FA again?
Total for the shaft.
Both are 47.5. Okay, both are 45.7 Newton. It's also 5.7 Newton. What about theta in and theta B? This one on shaft. It's on the shaft. What is the angle we calculate to measure? Anyone? On shaft mean that on polygon. On shaft mean that on polygon. And this one going to be your test 2 topics. It's not test 2 quiz, no, it's test 2 topics, which will be inshallah late of the semester, a week or 2 weeks before semester end. So anyone theta A and theta B? I think we completed this one, but I'm not sure about the number the numbers. No? Anyone? So if you don't respond, so very difficult for me to start with. Otherwise, I go to the next, topics. A 3. Okay, thank you. 3 2 3. The other one, I just because I cannot. I'm not very. 1 4 3. Thank you. 1 4 3. Thank you. Yeah, this one 1 4 3. This one is measured here. This one is theta A. This one, thank you. This one is theta B. Theta B equal to 1 4 3. This one is 3 2 3. So this is very important, yeah. And this one all on shaft. Okay. Could anyone tell me what you have this one for dynamic? Could anyone tell me this one for dynamic? Could anyone tell me what about statics? Remember static after modification? Static after modification, and you are very lucky here, modification, because when you add up and you minus, you make it the same results, isn't it? Due to static mass, static weight. So what you have the RA 98 volts. I thank you, done 98.1. This one is Newton, pointing upward, isn't it? Okay, this one shaft, yeah, this one shaft. Same thing, equal to 98.1, also pointing up. Okay, this one also on shaft, also on shaft. S H A F E S H A F S. So due to this parameter, I'm going to solve it. And let me open another file so that can easily. Okay, yeah, look at here. Okay, now number one, oh, number one, total force. Sometimes they call it total maximum force. Okay, sometimes they call this one is what they call it. Call it total force is already done, isn't it? Total maximum force. This one, total maximum force. Total maximum force on bearing A, for example. Okay, on bearing A. Look at here. You go back here, look at A. Okay, A, this one shaft pointing upwards. Correct? It is pointing upward. Bearing now is pointing downward. This one is bearing. Same thing here. B also now pointing downward is a bearing. Here is also same thing, isn't it? This one on shaft or bearing A. This one be on bearing. Same magnitude, of course, on bearing. This one same thing, it will be the other side or opposite direction. This one also on bearing. So you take all bearings, force. Sorry, you take all the force on bearing, then you add up together in vectors, of course. Yeah. So if I can start with A, for example, it's pointing that way and pointing downward. Yeah. So you will have a sort of, yeah, it's my starting point. It's pointing downward with the magnitude of A equal to 98.1. The other one will be, you go back here, okay, A will be pointing this one, isn't it? Pointing the other way. So this one will be your A. This one is your FA 45.7 Newton. with the angles. This one, yeah, that one 32, yeah, you can find yourself the angles one, yeah. So now for the total maximum force, you add up together this one. What does it mean? You bring this one, if I can change another color here, you bring this one, zap zap zap. Doesn't matter, you can rotate that one or you can rotate the one, doesn't matter. As long it will fall at, as long it will fall at statics. So you bring it down here, it will be falling here. Okay, because this one not done by scale, so you found that this one must be a bit longer. This one is 98.1. This one is 45.7 for FA. So therefore, you found that summation of FA, isn't it, for maximum is equal to, you add up together, and you're saying that pointing downward as positive, and you are saying that this one is FA plus RA, which will give you FA is 45.7 plus the other one is 98.1. Then you add up together, this one is pointing downward. Okay, it's not very difficult, isn't it? Or B here, so this one, number 2, total maximum force on bearing B. Same thing, go back here, where your B is, B will be pointing downward, B this one also pointing downward at the position as calculated or perhaps as measured. So this one pointing downward, B equal to 98.1 Newton. Then the other one is here, is FB is equal to, we have 45.7 Newton. Then again, you're doing the same thing, the same procedure as what we did earlier for the bearing A. Down here, you will have force here. So therefore, you have summation of bearing or dynamic force on bearing, the maximum force B maximum is equal to the FB plus RB, where you found that, and this one all on vectors here, of course. You have this one is 45.7 plus 98.1. You'll be getting here same one, and it is pointing downward as the boundary condition. Okay, it's not very difficult, isn't it? The next one, the next one is what? The next one is to define what would be the what would be this one, yeah. The next one will be the maximum and minimum vertical forces on bearing A and B. Look at the maximum, minimum. This one are both are maximum. Maximum for bearing A, maximum for bearing B. So now your maximum and minimum for bearing A and B vertical one. So you have the same thing basically, but now you're putting the other direction. For example, yeah, if I can do this one, number 3. This one is maximum and minimum vertical forces of bearing A and B. Put it here A. Go back here. Look the graph. One pointing the other way, the other one pointing the other way. So assuming that my graph is correct, FA is equal to 45.7 Newton. This one is RA is equal to 98.1 Newton, of course. And the angle that you measure or perhaps you calculate has been given just now. This one will be here, isn't it? is theta A is equal to 332 Newton. Okay. Sorry, it's not 32 Newton. I'm sorry. It's not 32 Newton. It's 332 degree. Degree. So you have 332. So this one, a small portion of this one, acute angle, we have 360 and 332. You have 28. This one will be 20. Am I correct or not? Yes or no?
Doctor,
Yes.
supposed to be 37 degree.
Oh, 37. This one, 332 or what?
323.
323. Okay, thank you. 323. Okay. 323. Thank you. 323. This one will be 27 is correct. 27 is correct. Okay, now they're asking about maximum and minimum vertical forces. What does mean? You have to resolve this one. How to resolve? You put it here. Of course, you can do this one, yeah, on the same graph. I just want to ensure that it will not be so messy here. I just put everything on one graph. So you will have one pointing here. This one BRA remain because this one already fall at vertical. The other one, this one here, and this one you have 27 degree. Then you resolve. This one is a FA by 45.7. You resolve it. This one becoming what? 45.7 sine 27. Am I correct now? You have another one. This one is 45.7 cos 27. Am I correct now? So therefore, summation of f, which we do not know whether it's maximum or minimum. What did you know is this one is on A is equal to your RA, which is pointing downward positive, plus your FA. And is equal to RA is 98.1 plus this one is negative because it's pointing the other way, which will give you 45.7 sine 27 degrees. Then you can get the results. Newton. I suppose this one you'll be getting positive because this is so small, isn't it? You'll be getting something. This one is pointing downwards. Positive means one you're falling, whatever you had, this one positive. You can also say that this one pointing upward is positive. It doesn't matter because this is what you assume. This one you assume. You can make another assumption saying that pointing upward is positive. And you do not know. You do not because this one you have possibility of maximum. You have possibility of minimum, which we do not know until you create another force on bearing B, for example. Is that clear, class? Then let's say we move to bearing B. Bearing B, you go back here. Bearing B, oops, sorry. Where are you, bearing B? Bearing B, this one. This one. So many file open. That's one. Bearing B. So both are pointing downward, isn't it? So both are pointing downward. So you put it there, bearing B. One will pointing this one, which is RB equal to 98.1. The other one is here, which is FB is equal to 45.7. And you already calculated that the position, this one, remember, is 143 degrees, which is this one is theta B. This one is on shaft, isn't it? Remember? This one is on bearing. So if you have 180 minus by 140, you'll be getting a small portion. This one is 47 degrees. Sorry, it's not 47, it's 37. Sorry, 37 degrees. See, right? Because this one is 37, This one just now 27, correct or not? Or this one also is not correct. This one is not correct, class. This one 3 and 2, this one is not 27. This one is supposed to be 37, isn't it? Yes or no?
Yes, Doctor.
This one is supposed to be 37. So this one, the whole thing will be 37. This one 37. This one also 37. Because I do find that the angle is the same, so we're getting the same angle. So now what you have to do now, you do this one, what? You have to, if I can draw this one, yeah, if I can draw this one, so that it will not be messy, the one, so many things. So this one is for FB equal to 45.7. Then you, what you have to do is you what resolve into x and y. This one is a small portion of angle is 37. So you'll be getting this one is 45.7 cos 37. The other one here is here. This one be 45.7 sine 37. Okay, now summation of f on bearing B, saying that just now we are saying that any force pointing downward is positive. The same boundary condition will be applied here, positive. So we are saying here RB plus by FB in vectors, of course, is equal to 98.1 plus the other one is this one is 45.7 sine 37. Then you have a numbers here. So you have the possibility saying this one maximum, saying this one also minimum. So could anyone tell me what you have this one? I don't have a calculator next to me, yeah? Anyone? 125.6, thank you, 125.6. The other one also the same thing, isn't it? Yes or no? This one is what? This one is smaller, 70.6, thank you. Then you can decide that this one is minimum, this one will be maximum. Okay, so that's about it. It's not very difficult. So perhaps you have to proceed with the numbers. For example, the question might asking you which bearing have a tendency to fail first, regarding with the maximum and minimum vertical force. You are looking for this 125 and also 50. If they're talking about maximum force, you are talking about this one. Where are you just now? This one, yeah, these boats. So you have to read the question very careful, referring which force the question asks you. Okay, so now I'm going to ask you typically for the CTPS again, CTPS. Explain what happened to the axial force on each bearing. So tell me, explain briefly. Explain briefly, a short one. What happened to the axial force on each bearing? You go back to the figure. You go back to the figure and you look at the force. You look at the vertical one. Oh, sorry, horizontal one. This horizontal one, isn't it? Then you go back to the other one, and this one is the horizontal one. So what can you say about it? What can you say about it, class? Anyone? Yes, thank you. Cancel out each other and become 0. So there is a very small, a very minimal axial force on bearing, and it is sometimes not counted. It's not counted, meaning that it's already already we've already designed for the bearing to overcome all the axial force. Okay, I'll run through the your notes here, your tutorial. And have you copied this one whole thing before I move to the next one, or you make this short screen screenshot or print screen? I think you make a print screen is better for you, yeah. Then you can easily you print screen and then you copy to words. I think you better know better than me on applying all the gadget here. Huh? Okay, I'm going to move to this one uh, based on what we have here. And for problem number 2, is basically about the same. Is basically about the same. Number 3 also the same thing. I'm not going to do the one. Determine the maximum minimum vertical force bearing if the shaft rotating about 300. What is the maximum bearing? Remember, what is the maximum rotation speed? This one is adjustment. Let's see this one. Yeah, for example, this one problem number 3. You have figure 40. So let's say NA is equal to 100 RPM. Then you calculate another one. NB is equal to 200 RPM. So this one become maximum. Okay, we already done this one. I already discussed one a couple of times. Yeah. Example number 4 also about the same. Only the different thing now is I think I already discussed about this one. Yeah. For the example number 4 here, because they provide you here, because they're asking about what? They're asking about the eccentricity. Calculate the radius of eccentricity. So it's so definite that the equation coming from this one, omega squared. This one must be given. This one, this one from polygon, this one must be given. Otherwise, you cannot solve the equation. You cannot solve the problem. So the arm, what you need to define, this one is given. Look at them. They provide you 3000 RPM. So your R now is unknown. Okay. Number 5, I think also not a very difficult one. I'm quickly go to the one is so what do you call it, rare. This one, question number 7. Look at question number 7. Look at number 7. Okay, figures show a turbine blade. You know that, as I mentioned in my first class, turbine blade, there's not 6 blade, 100 of blade for turbine, typically for turbine. But I bring only the 6 blade because we don't have ample of time to solve everything. But I can pretty sure say that if you can solve this one, if you meet any problem related to the turbine blade, inshallah, you can solve with this method or what we will discuss here. Okay, we have 6 blade, ABC up to E, ABC up to E and F, with 2 gears G1 and G2, G1 and 2 connected to the input, for example, or connected to the output, for example. It doesn't matter basically. And supported by 3 bearing B1, B2, and B3. Okay. Initially, the center of gravity of the blade and the center and gear are about the axis of rotation. And I already mentioned this one. This is the definition for this one. Yeah. This one is definition for one, totally balanced. Totally balanced. Okay, totally balanced mean what? Mean that the blade and the gear are about the axis of rotation of the shaft. After some time operation, meaning that this one no modification be done manually, but it will be the modification is done naturally when you have a lost mass, so on and so forth, added mass. Sometimes you added mass due to the oxidation. You know that the oxidation occurs when the reaction due to the steel, the wet steel, and the oxygens or H2O, and perhaps you will have a rust where you found that when you have a rust, when the system when the body will be rusting and it is a loss of mass, and you found that 0.4 kg loss at 0.2 at the position. This one is the same thing, 0.2 loss at the position only D and F. The rest remain as it is. So you have what? Calculate the mass should be fitted on bearing G1 and G2. So this is the place of correction. G1 and G2 is the plate for correction. Yeah, so that the turbine is well balanced again. So you use G1, G2 as part of your correction plane. This one, we call this one correction plane. Okay. Following are the mass of the blade. So you have A, B, C, D, E, F are all provided. So my question is, what will be your parameter or plane, for example, or plane perhaps in your tables? Tell me. Otherwise, you have to put B1, B2, G1, G2, A up to F. So you have 1, 2, 3, this one 2, 5, another 6, 5, 11 plane. So could anyone tell me which plane will be used to solve the problem? Anyone? And this one is quite different compared to others. DF, G1, G2 is correct, yeah? DF, G1, and G2. So this one is correction plane. This one is defected plane. It's defected, yeah. Defected plane. The rest which is not defected, for example, yeah, A will not change anything, B will not change anything, whereas C also not change anything, E does not change anything. So what does this mean? Yeah, what does it mean? It simply mean that if you have M here, yeah, this one you have remember the column, this one you have R, isn't it? If you put A, for example, yeah, so there is no there is no basically lost mass, isn't it? There's no lost mass here. And you have R here is equal to 0 because why? There's no eccentricity due to the mass that lost due to natural defect or wear and tear reactions. Okay, so you have to very careful with this kind of problem. And you do not concern about B1, B2, and B3 because there is no force as so plane B1, B2, B3 is what is ignored, isn't it? Because there is no force being asked, so there is no bearing plane in your table. So you have only DF and G1 and G2. But when the question keep asking, for example, part 1 and part 2, isn't it? So the next one, what be the force on bearing? And then you have to include all the bearing planes. Yeah. Number 8, also not a very difficult one. This one, look at here. Now they're asking about what would be strength, meaning that you have to put this one and this one. Along the line, you also need to select which part will be defected. Problem number 9 is not very difficult. You can do this one on your own. Number 10, also same thing. 11, I think that's about it. The only different, this one, yeah, I already mentioned about what would be the radius typically for A. The rest, I think, if you can do the whole thing, this one 16 and also about 20 something patient on your own. Of course, you have your friend with you to help you. Inshallah, in test 2, you will not face any problem. Okay, so that's about it, class. Any question before we move to the next topics? Okay, now I'm going to move to, thank you, Lee. I'm going to move to the next one. So I will move with this one. And I'm going to share with you. I have to stop sharing this one because I need animation. I know that I promised you to share with you the video. It's very fortunate that it's very unfortunate that I can't find where is the video is here. When I can get the video for the static balancing, I will share with you again, inshallah. I keep searching at the moment now. Okay, now you have this one on balancing of reciprocating mass. So before we start anything, you have to define what is the reciprocating. Early was the rotating, you know what that will be rotating 360 degrees. clockwise or counterclockwise doesn't matter, but it will be rotated 360 degrees. When you're talking about reciprocating, it is not rotating basically. It will move backward, forward, backward, forward. So if you relate this one with in engine, for example, yeah, talking about inline engine, for example. So we are basically focusing on the piston. So the piston will be what? Will be moving backward, forward, backward, forward. Or in automobile, for example, we are talking about or in engine, for example, you're talking about what? Top dead center to bottom dead center, top the center to bottom the center. So that will be the stroke. Okay, but of course the piston attached to connecting rod and also attached to crank. The crank not only make the rotation. So I will show you later on. Yeah, what will be the animation of this kind of problems. Yeah. So we are going to talk about three different engine here. If I have ample of time, I try to share with you what happened. We are talking rotary engine or mid rotary engine, basic for the mid engine system with high power and high capacity engine. First, we are going to look for very conventional engine, inline engine. Everyone know about inline engine, radial engine, which is very famous at the moment now, talking about range and also the V engine. If you if you go for the vehicle, for example, everybody now look for V engine because they do find that the performance is so good and also good handling, vibration also very minimal compared to the conventional inline engine. But there are some other measures saying that the V engine is not it is not so good now. It's not convenient comparing with the inline engine, talking about maintenance, for example. Yeah, I'll be talking inshallah about them later on. Yeah. Okay, this is what we have here. If you can see my cursor here, this one is inline engine. We have 6 cylinder. You have this one also 6 cylinder, but for the arrangement of the V engine, this one have 5 cylinder for radial engine. And very quick definition saying that for the inline engine, you found that the the crank yeah, attached to the shaft. They call it crankshaft. And of course, the crank also carrying what you call as this one as the connecting rod, and the connecting rod is attached to the piston. Okay, so the one that keep rotating is the crank, where the piston is on reciprocate from backward, forward, or in the terminology of automobile, we call it the no, top dead center and also bottom dead center, TDC and BDC. For the V engine here, you found that it be located at the V notch. We call it the V engine, the V notch, and you found that one crank, this one here, carry 2 cylinder attached to connecting rod 1 and connecting rod 2. Then you have another one. So when you found that a crank carry 2 cylinders or connected to connecting rod, we call it the bank, BANK. One bank, you have 2 connecting rod and 2 cylinder. So in here for 6 cylinder, you have 3 bank. Bank number 1 carrying cylinder number 1 and 2, bank number 2, 3 and 4. The next one will be 5 and 6. Okay, bank, remember that? So that BANK. The other one is for the radial engine. Yeah, look at here, this one radial engine. You found that same thing here, but the arrangement is one circle, isn't it? It's one circle. This one is horizontally, this one also horizontally in V notch, of course. This one be in circle. And you do found that in circle, meaning that what the crank will be rotating 360. But this piston is still in motion of reciprocating backward, forward, backward, forward. And the arrangement of this one, every connecting connected to a single crank. Okay, so that is the difference. So this one you can read on your own class. It's not very difficult. This one. The thing that I want to highlight is the resultant of all forces acting on the engine due to the initial force. So we are going to look for this one after this one. What is the initial force? Okay, we are going to look the initial force. It's very important. Also known as unbalanced force because we do the other, the other topics in rotating mass is we call it unbalanced mass. This one we don't call an unbalanced mass. Typically we call initial force, and these two parameters are the same. So the purpose is to eliminate the unbalanced force and couple. Okay, unbalanced force and couple. The other one also we have couple and force. So we are trying to eliminate, or perhaps if you can't eliminate, we basically make the force and couple so minimal. Most mechanism of the unbalanced force and couple can be reduced by adding appropriate balancing mass. So you have to add something on the system. It is not adding something on the piston because the piston is so identical. Because we are not talking about compressor, for example. You know well that compressor have different stages. Stage 1, stage 2, 3 stage. So as the compressor has many stages, what does this mean? The piston is also have so many sizes. Here, the piston is so identical to others. It is not the piston, but also the connecting rods. This is the main objective here. In other words, because it's not done for practicals, yeah, the reciprocating mass are only partially balanced. I will explain this one when we meet an example. If I explain this now at the moment, because I think you cannot basically imagine, yeah, what been talking here. So just remember that you cannot eliminate 100% of the engine due to cannot be done in practicals. This one cannot done in practical. Then we call it as partially balanced. Typically in the exam, yeah, they asking about what do you understand by partially balanced. I'm going to explain later on about the partially balanced. Yeah. Okay, these are the things that we're going to discuss. We're going to discuss initial force, as I mentioned earlier, on the reciprocating mass, of course. Then we also need to know the position of the crank, and the position of crank is depending on type of engine, because it's very dominant that in a day life you have the engine of 2-stroke and also 4-stroke engine. So we need to know what will be the crank position for this type of engine. Then we are looking for crank diagram, which is primary and secondary. And this one is very new to you. What is the primary? What is secondary? Force and also moment. So you have primary force, primary couple, or primary moment, secondary moment. Sometimes we call moment, sometimes we call couple, but basically these things are same. Balancing of the reciprocating mass in different planes when you have multi-cylinder. It's not multi-stages of engine, yeah? It's a multi-cylinder. It's not only one cylinder, you have up to, for example, 10 or 9 cylinder, for example. So the unbalanced force will be based on primary and secondary, as I mentioned earlier. So do you understand that if you are constructing this one by graphical, for example, you will have 4 polygons. There is no longer 2 polygons. Yeah, you will have 4 polygons. 2 polygons coming from the force, the other one coming from the couple or moment, which is primary force and secondary force, primary couple and also secondary couple. So you have 4 polygons now. So of course you need more time to solve, and then you need to practice here. This one is nothing new to you. I think everyone has been exposed to this one. The arrangement of the numbering of the cylinder is basically given, sequentially 1, 2, 3, and 4. But on the other hand, you also have another one. We call it firing order, which is not given sequentially. Firing order is not 1, 2, 3, and 4. Will be provided by the manufacturer, engine manufacturer, of course. Yeah. The other thing you have to understand here is, if you look at here, for example, class, this one is 1, 2, 3, and 4. Look at here, 1, 2, 3, and 4. So the arrangement of cylinder 1, 2, and 3, and 4, if you look at here, you found that the movement, cylinder 1 and 4 will have same pace, PACE. Same pace is same movement. The next one is 2 and 3 also having the same pace. Okay. Because we are talking about internal combustion engine, you know that when you're talking internal combustion engine, you will have 4 activities, which is what? Which is induction. The next one, what? After induction is combustion, then power, then exhaust. So these are all the activities you have to understand in the internal combustion engine. Okay. This one just to share with you what is basically how does the engine look like in the real situation. Even though this one all the animation, yeah, this is the actual engine, this one is the animation. Okay, So first foremost, I'm going to define is the initial force due to the reciprocating parts. Look at here the initial. Do high initial. So look at here. So supposing you have so many cylinders, you open up one cylinder, you put here and do as an analysis. This one we keep rotating as what you have. This one is keep rotating the crank. Yeah, the crank we keep rotating. The mesh will be keep what moving backward, forward, from BDC to TDC. Then you pause a bit. You pause a bit. It become as what you have here. This one you pause a bit. It become this one. When you pause it, you find that all forces acting on the bearing. For example, this one now, force BH will be bearing horizontal. This one BV is bearing vertical. This one is the combination of bearing, force on bearing. This one on the mass itself, because this thing also keep moving, isn't it? It's keep rotating. There must be a friction along the line of the cylinder. So you found that there were another force FR here. FR is the what you have the required force to accelerate the reciprocating parts. And because the piston also touches the cylinder, you will have this one Fn, normal force. Remember, when two surfaces contact to each other, you must have normal force. Like the wheel contact the floor, the surface, the road, there must be a normal force. Excuse me. And the other one is you have this one Fi. This is our concern now. If you look at very detailed, yeah, you found that FBH will be cancelled with the Fr. You found that the FBV will be cancelled with Fn. Finally, this Fi will not be cancelling to anyone. So you are going to look for the Fi. So the initial force here. So before you do the initial force, if you remember in discussion here, if I can have going to share with you the blank just now. Astaghfirullahaladzim. This one, yeah. Okay, yeah. Our concern just now, we want to look for the initial, isn't it? So let me focus on this one. Okay, this is the engine, one cylinder. This one is the piston. Piston move with M. This one is connecting rod. Connecting rod. This one is crank. When you have a single cylinder, we call crank. When so many cylinder along the line, we call crankshaft. Yeah. So this one, of course, be rotating that way with the omega, and this one we keep moving backward, forward. So as it move here, we will have F. That one is Fi. Is equal to the Ma, or perhaps in other words, it can also be written Mx double dot. So because you have you have X with the rectilinear motion, you have X dot the velocity, you have X double dot. This one is linear displacement. This one is linear velocity. This one is linear acceleration. So we are going to look for this one. But then before you do anything, you have to start with linear displacement. So what is the linear displacement is basically this one, X. Okay, we need to know what is one X. Because this is the only introduction to the balancing of reciprocating mass. I'm going to, I'm going to keep this one as a very small portion of your derivation of X. For example, we start with this one. You can open up your books, turn to page, turn to page 123. Okay, if you want to go in further talking about this definition or perhaps this calculation, you need to join me back in your later year of your study on the condition monitoring, typically on engine. Yeah, we are going to do this one in detail. Here is the introduction. So we finally want to define what will be the X here or X here. This one is the motion backward, forward, backward, forward. This one is due to the arrangement of the crank and also the connecting rod. So this one is displacement, linear displacement. This one also, this one theta is angular displacement. So our concern is to look for the linear displacement because we are dealing with mass on a piston. So look at here. So start with this one, this X. Don't bother about what the R cos theta and L cos theta is. Basically the arrangement of the whole range here. This one. You have to look for what's small here and small here. Then you get the whole thing. Okay, don't bother about that one. What you need to understand is, oh, you need to find X. Yeah, after do some, mathematically, typically on trigonometry. So finally you be getting as such, this one. Again, do not bother about this one. Then you start deriving, with respect to time because you calculate only a portion of angular of the linear displacement. This one we keep moving and moving with respect to time. You be getting as such, which will be in terms of velocity. Then you keep deriving it, you will find this one. This is the most important thing. So remember this one. Remember this. Okay. Then you take this one and put it in your equation just now. F is equal to mx double dot is equal to your m. Then the whole thing, which will have omega square. This one be r cos theta plus r squared divided by L. This one cos 2 theta. So you have L. This one. This is what we call Fi just now initial. And we can also simplify up to the very minimal equation so that you can easily memorize is this one. Then you split into two parts. Look at it, you open up the bracket, it will split into two parts. This one, the first part, we call this one as primary. The second part of the equation, we call it as secondary. This is the unbalanced is equal to Fi. Okay, if I can go back to your notes, you will have as such this one. Here. You still have a couple of minutes before we end our session on this one. Okay, class? And of course, you need to know what the N. N will be the ratio between the connecting rod, this one earlier connecting rod, divided by which is this one, radius of crank, or crank radius. Okay. Any question? Any question? It's not very difficult, isn't it? Very interesting here. And this one just to share with you, when I split into two equations, you'll be getting as such one and the other one here. Okay, and finally we come to this one. This one, another one. How basically you balance the system. This one, you use this one. We want to balance. How basically we balance the system. So we go back here. From the first lecture, I did mention about if you have one mass here, this one is m, this one is omega, this one is constant. You aware that you must have Fc equal to m. This one is m a n is equal to m omega square r. Correct? If you want to balance the system, you must have another mass. And this one will be exactly, you copy back the force. This one is Fc equal to m a n also equal to m omega square r. Or perhaps if you do not know what the omega, it can be in another form. Okay, now it's balanced. If you let it in stationary, so the system will be totally balanced, which will give you this one. It will be in level. This one in stationary. Okay, same thing you look at here. This one is, this one will be what we call balance mass. Okay, balance mass. So you go back to here, you know the knowledge, you go back to here. So if I can, relate with this one, yeah, this one, you have F, which will give M omega square cos theta first. Let's see this one primary. Okay, this one, and you know that this one is the piston identical, meaning that piston 1, 2, 3 are so identicals. Also connecting what are so identical, connecting what also identical, also identical. So you can take this mass, you put it here. If this one is M, you put this one also M. Which we ignore, we ignore the connecting one and also the piston, because we know that this one are identical. And you cannot put any mass on piston or any mass on the connecting one, because this one will be disturb the rotational of the system. So you have to put M here. Okay, but then you found that you go back to here is exactly as what we learned in the balancing here. Correct? You need to put something. Okay, now here you have mass. You need to put something the other direction. There we saw it come this one. Okay, of course, when you when you resolve the equation, this one is F just now. This one, let's say about theta, be rotating that way. So this one also F. Correct. That one also F, isn't it? But remember the equation just now? Fp cos, sorry, it's not Fp cos, Fpm Sp equal to Mr cos Mr omega square. Mr omega square cos theta. So same thing here is equal to Mr omega square cos theta. So this one be F. This one be sine. This one M omega square R sine theta. And you have this one same thing. This one must be F. This one is if the equation asks you how to balance the engines, yeah. This one is also F. A bit more, yeah. F. And you have another one horizontal, which will give you M omega square R cos theta. This one will be M omega square R sine. And you found that everyone can automatically cancelling each other. And the system now is totally balanced. Okay, that is what you have from what in your notes. When you add up this one, if I can make it a bit bigger, this one and this one can cancel off. This one and this one cancel off. This one also cancelling off. And this one cancelling off. So the system now is totally balanced. So the problem now, how are you going to do this one on the engine? This one, how to put this mass in engine. So we go back here. You go back here. Look at here, class. Go back here and look at here. These are the balance. So there is no added mass on the piston, but there is a what we call it crank. We put something on the crank, it becomes crankshaft. Okay, so there is no mass on the piston. There is no mass on the connecting one, but you have this one, and you found that the design of the crank will be so different. Look at here, this one, yeah, is so different compared to others. You understand me then? So if the question asking you, for example, yeah, explain a bit about balancing of the engine. So these are the things that you are going to answer. Of course, I can't put this one in word. If you look at my note there, inshallah, they are put in sentences. Here, I'm going to explain how do you basically balance in practicals. And once you know that, you can put in your own words. Okay. Any question? Not interested to us on this topic is not interesting? I think this is the interesting topic because you are engineer, you know, exposed to this one. Excuse me. Any question, class? Okay, thank you, Ko. Okay, the next one I'm going to look. Remember, you have what? You have primary and secondary force. We're going to look for secondary force now. Excuse me. Secondary force. Same thing for secondary force. The only difference now secondary force is what? This one you have a different region. You have theta. You have this one cos to theta. This one you don't have n. You have n here. The rest of the term is equal. Huh? So I'm going to explain how the balancing of the what do you call it, of this secondary. Same thing. This one F secondary. F secondary. You put mass here, then this one acting at horizontal plane. You know that this is the component horizontal. There must be another component on horizontal, and this is the results. How to balance? You put the mass basically opposite direction with the same radius here, and this one be cancelling this one, pointing the other direction, pointing the other direction, and pointing the other direction. But remember, you have to put this one 2 omega. Need to put this one 2 omega. So this is the reason why. Yeah, listen up very careful. This is the reason you have to give 2 omega and you have to give to put 2 theta to the system, to the engine. Yeah, basically put it to engine. To the engine. Just now, you have 1 theta and 1 omega. This one 1 omega and theta normal can be done in practical. This one, you have to place 2 theta and you have to run the engine twice. So, which is impossible to be done in practical. You understand your notes? Which is impossible because you have to run the engine twice and you have to what? Push the crank twice of the position, which is not, you know, not possible to do in practical. That is why we answer back from the first part of our lecture. That is why, what does he say just now? What does he say just now, class? Anyone can remember? What does he say? What does he say just now? Anyone? Anyone? Hello? Could anyone respond? Yes, partially balanced. Thank you, Tan. This one. Partially balanced. What does it mean? Only what? Only FP can be done, not FS. Due to what? Due to 2 omega and 2 theta. This one is omega and theta can be done. This one cannot be done. You have to place the crank twice of the original position. You have to push, which might, if you push the crank will be broke or breaks. And you have to run the system or the engine twice, which is impossible to done in the practical. Okay, so that is, no, I already answered the equation why it's only partially balanced. Okay, another one I would like also to mention here is regarding this one. Look at here. You know that as I put this one, yeah, the crank, the piston will be on horizontal. This one, your engine will be acting horizontally, which is not in our engine here, isn't it? But this one is basically of what you have in your engine, where your piston now in vertical. So as this one in vertical, you will have to split 2 mass. One be one-sided, the other is one-sided, one after another. Both sided, you have this one M, half M, this one also half M. How do you configure this one? You go back to the if let me see if the You have this one or not? You don't have this one. So you go back to the last figure just now I mentioned. We have two-sided in it because you are doing this one in what? In horizontal. Look at here, you have two-sided. Okay, here one, the other one. Can you understand me or not? Can you see that one? Let me clear the whole thing. Then going to write this one. I want you to understand this one. This one side, the other side. This one is m by 2. This one also m by. Okay. Okay. We move to this one. But of course, in calculation, you don't have to do that one. Yeah, just to explain to you how easy in the actual thing. Why you find that you have two pieces of your crank because you are placing the M half and the other half. Huh? Okay, this one is not very difficult. Just to share with you, yeah, the position of the crank. Look at here. So look at here. This is the radius. Yep. Put it here on this one. This one is the radius, isn't it? Or perhaps the radius vertical, pointing upward, pointing downward. So you will have this the radius, this also the radius. So sometime many book will be define the engine as this one. And if you look at one sided, for example, this one, you have this one 0 degrees, 90 degrees. This one is 180. This one is 270. Okay, now you tell me, cylinder number 1 placed at what position? Cylinder number 1 placed at what position? Come on. Anyone? 270, correct. This one 270. This one is 90. This one is what? This one is also 90. This one is 270. You have to know this one. If supposingly the arrangement is keep changing, yeah, this one because sometimes different engine with different position, so you might be getting as such. You might be getting 0, 90, 180, 270. So this one also keep changing, defining by different reference position. So you be getting here as this one 0, sorry 180. This one is 0, 0, 180. So this one typically, this one are typically given in sentences. They're mentioning, for example, yeah, the position of the crank is 180, 0, 0, 180, where 0 is the vertical and counterclockwise, for example. Then you have to understand this one. Okay. Okay, I'm going to look for another one, another subtopic here, talking about the crank, for example. Yeah, look at here. If you look at one-sided here, remember we are going to do what? We are going to draw crank position. We are going to draw crank position. What is the crank position? You go back here. The crank position is basically this one. This is this one. This is the crank diagram. This one is crank diagram. We are going to draw this one with the position, of course. Yeah. This one for only one cylinder number 1, for example. You have another one, number 2, 3, and 4. So what we can to do now? Okay. So this one, for example, if you draw the, if you stand at one point here, so could you tell me how the crank position now look like? Okay, number 1, where will be number 1? At top, am I correct not? Because this one at top. Number 2 be here, number 2, correct not? Number 2 here. Number 3 be at bottom, number 3. The next one is number 4. So that will be the position of crank when you look at one point. Does it balance? We do not know yet. This one is to talk only the crank position and also crank diagram. And this is what we call as crank diagram. Okay. Okay, now. You know well that most of the engine is not only a single cylinder, typically coming from the multi-cylinder. So when you have a multi-cylinder, you have a moment or couple. Sometimes we call couple, sometimes we call moment. How is it? It's basically also coming from the this one. Let me share with you. You have this one or not? Or you don't have? Never mind. I will start with this one. Much easier. Look at here. Hold on, I'm going to clean up this one so that easy for you to understand. Okay, as I mentioned earlier just now, this one you create a force which will give you m omega square r, isn't it? Same thing here, same thing here, same thing here. Of course, you have m omega cos theta plus some, something. Put it just f because it's very long equation. You have f1, f2, f3, f4. Or if you're talking about only one cylinder, so there is no moment. But when you talk about more than one cylinder, we call it multi-cylinder. You will have this one from one plane to another plane D. So if for example, yeah, sorry, if cylinder number one, for example, as a reference here, for example, yeah, so you will have one, you will have this one multiplied by D, you have a moment. So moment or couple equal to F2 by D. The next one be measured here. This one, let's say this one D2. The next one be M equal to another one. So now you will have couple. So what is couple? You have another equation, this one. Oh, sorry. Only the different now you have D. You have the rest of the equation is exactly the same. And again, you have the primary couple and secondary couple. Primary couple, secondary couple. Where the primary couple is only cos theta. The primary is only cos 2 theta divided by n. Okay? An equation. So in conclusion, when you have multi-cylinder, and obviously we are dealing with multi-cylinder, so your F is equal to, put it unbalanced, m omega square r cos theta plus the m omega square r cos 2 theta divided by n. This one is the F primary. This one is the F secondary. Okay. On the other hand, you have m also unbalanced is equal to the m omega square rd cos theta plus m omega square rd cos 2 theta divided by n. This one is what we call as m primary. This one is what we call as m secondary. Now I'm going to explain to you what is theta. Theta is crank position. Theta is crank position. You need to know the crank position. So the crank position, which theta can help you to solve the F, to solve the M. A part of that is also to construct crank diagram. Okay. So of course, before we do the crank position, you need to know another parameter to create or to construct crank diagram. We need to know the firing order. Okay, so I'm going to explain to you what is the crank position. The next one is the firing order. Before that, I also need to explain to you N just now. What is N? Is the ratio between the connecting length of connecting rod divided by the radius of crank. So I'm going to explain to you this one before we go further. Okay. Now, I'm going to stop sharing on this one because I need to show you the animation. Then you give me the results. Yeah, I'm asking you now. It's not very careful, this one. Okay, now put it here. You have one cylinder because of course we need to start with one cylinder. Okay, yeah. So the crank position, as I mentioned earlier, depending on type of engine. You have two type of engine. One is 2-stroke, the other one is 4-stroke. Okay, supposing you have this one. We do not know whether it's belong to 1-stroke or 2-stroke. We want to look for what is the stroke. What is stroke? To you, what is stroke? What is stroke to you? Stroke is the what? The displacement between BDC to TDC. That is one stroke. So stroke is movement of the piston from BDC to TDC. So when the system or when the piston move from TDC to BDC with one stroke, it go back to a TDC to BDC another stroke. So if you look at very carefully here, you make the system will make 2 stroke with 360 degrees, where 1 stroke will give you 180 degrees. Yes or no? Yes or no? Yes or no, class? No response? You understand me or not? Okay, now. So let me share with you now. I'm going to go back to this one. Stop sharing. I'm going to share with you the calculation now. Look at here. This is a small L. This one move backward, forward, backward, forward. Supposing at this point, so it will be, at the highest, at the longest point, farthest point here. Then it will roll here, and this one here will stop at here. So now we'll go to here. This one, let's see, this one is TDC, top dead center. This one is BDC, bottom dead center. It will give you one stroke, which will give you 180 degrees. There is no 1-stroke engine. You have 2-stroke engine. So it must be moving or rotating another circles. Zap, 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 zap. This one, this, move to the next one. Stroke number 2, 2-stroke, which will give you 360. So theta is equal to 360 divided by N, which we do not know what is N is, because we are talking about one cylinder, N will be N cylinder. So this is for what? For 2-stroke engine, where N is equal to number of cylinder. Understand me or not? Then you keep moving another one, move to here. Then it will move, piston move to the next one. So here is this one, that one, move to that one. Let me change another color so that you can differentiate, yeah? Move it here. This one still BDC, still TDC. Move that way. Another stroke. Now third stroke. You don't have engine coming from the 3-stroke. You have 3-cylinder, yes, which is Diva-Kanchi, so on and so forth, small capacity engine. And it will move another one, move to that one. Another stroke, we will call 4th stroke, 3rd stroke, 2nd stroke. This one is 4th stroke. Then you have what? Another theta equal to 4 stroke. This one is 360. Another 180 become what? Another 180 become? Another 180 become 360 by 180 become anyone? If you don't respond this one, I will leave it like that, and you have to, you have to read on your own because you have note with you. So the next one,
720.
no, the third one,
Or third one, 540.
540. Thank you. Then only 720, isn't it? Then you have 720 divided by n. So this one is for 4-stroke engine. And what is theta? Is the crank position. An equation. So you have two equations for 2-stroke engine. have theta equal to 360 divided by n. For 4-stroke engine, you have this one theta equal to 720 by n, where your n equal to number of cylinder. Okay, that is one. Look at the another one. Another parameter that you have to know this one. Look at there. This is R, correct? Radius, isn't it? Correct? So it start here, then you move. It start here, then you move here. This is L. Then you will move up there. Correct now? You have this one, isn't it? So now look at there. L is equal to R. Where your L is small L here, what we call as stroke or length of stroke. The capital L, this one is for the length of connecting rod. Different, yeah? So supposingly the equation give you N now is equal to L by R, and R is not given. This one not given. Yet you need to know what N is, because otherwise you cannot define or you cannot what calculate the secondary parameter for moment and also so what you have to do now is they must provide you L. L is what? Length of stroke. Then you know the L equal to R. Then you can this one. Okay, so I think that's about it on the first part of the first part of the lecture. Before we leave here or before we stop here, I also need to know this one. Yeah, I also need you to understand about the firing order a bit more. We have another couple of minutes. This one, yeah. When we come back here, inshallah, we are trying to solve everything in constructing the crank diagram. So what is the firing order? So I need to share with you the animation as I mentioned earlier. Many animation can, it's interesting compared to the non-animated. Yeah? So if you look at here, this one, the firing order. So this is the firing order. So the firing order is basically the sequence. This one, look at here, the sequence of power delivery. Okay, the sequence of power delivery. You hold on a bit there, class. Sorry for the interruption. Okay, look at here. The firing order is basically the sequence of power delivery. Remember, as I mentioned earlier, the activity is the induction. The next one is compression, then power, then exhaust. Power mean that the engine now giving power by what? By of course immediately after combustion. Then only you go to power then exhaust. So in multi-cylinder engine, for example, they need the spark plug to give what? To give what? To give firing, isn't it? Of course, the spark plug and also the fuels and also the oxygen, right? But for the engine, there is no spark plug basically. Sorry, for the diesel engine, there is no what engine for the diesel. What is the diesel use? Is the injection of the fuel, isn't it? In it, the injection of the fuel, then it will sparkle, then it will be fired. So I'm not going to talk about sonity. I'm going to talk about the sequential of the power delivery. For example, yeah, look at here. When you found that this one, yeah, combustion, we have the power adjustment, isn't it? So look at here also. We have 1, 2, 3, and 4. Look at here. You see this one, the what they call it, this one, the meter running from 1, 2, 3, and 4. So look at the spark. So that's the arrangement of from intake, compression, combustion, and exhaust. Okay, now look at here now. Next. So different engine will have a different firing order. For example, yeah, pick one. I'm not comparing whether it's not is good or not good. No, I'm basically asking, sharing with you different engine or different type of car will have a different firing order. For example, Honda Civic 1.8 VTEC, for example. So the firing order is this one, and this one you have distributor, and distributor will be rotating clockwise from your seat. So what does this mean? This is the arrangement of the engine. If you look at my cursor, yeah, the arrangement or the sequential number of engines 1, 2, 3, and 4 toward your left. But the firing order give you 1, 3, 4. What does this mean? First, cylinder number 1 will fire. Then cylinder number 3, 4, and 2. Very rare you found that the engine number is equal to the firing order. No. How do you design 1, 3, 4, 2? Is the manufacturer or the designer of the engine. Okay, this one rotating clockwise. They provide you 1, 3, 4, 2. Look at the other one. This is what? This is the BMW X5 E3. So look at the arrangement. The arrangement is 1, 2, 3, 4, 5, 6. We have 6 cylinders. So what will be the firing order? Look at the firing order 1, 5, 3, 6, 4, 2. How do you find? I'm going to explain to you later on how to design the firing order. At the moment, now just to know what is the firing order. Okay, so look at the difference from the BMW and also Honda. Okay. The other one will be for the V engine, for example. Yeah, you found that the V engine, even if you found the V engine with 8 cylinder, for example. But when you're talking about different type of engine, you have a different type of firing order. Look at here. This one is the Chevy. Chevy, this one is the Ford V8. Both are V8. This one is rotating clockwise. This one is rotating counterclockwise. So the rotating clockwise, you found that the firing order will be 1, 8, 4, 3, 6, 5, 7, and 2. Who decide the engineer will decide this one. The other one will be rotating the other direction. Who decide? The engineer decides one. Okay. This one just to share with you another one. And finally, you have the arrangement of the firing order. This one. The arrangement will be from 0, 180, 360, 570, because you're talking about. If you have 470, what does it mean? If you have 470, what does it mean? It belong to 4-stroke engine. Okay. And this one is basically show you the actual firing order. For example, look at here. Focus on the thing that keep blinking. Yeah. Look at here. First, okay, start with number 1 for now. Okay, yeah. Okay, now start number 1, then number 5, then number 3, then number 6, on and on and on. And this one is occurring in split in very quick, yeah, in blinks of eyes, very quick one. Okay, so I hope you understand what is the firing order. So when I meet you again, inshallah, I'm going to share with you how to use the firing order on constructing the crank diagram. At the moment, I cannot share with you, because if I share this one, you will end up with the half notes only, or half discussion. So I'm going to talk you this one by applying this firing order with the crank position. We are going to solve this one. So stay tuned, inshallah, next lecture. Really hope that you enjoy my lecture. So we have we have the test next week. So I'll be giving you mock-up test at night time. Check your group, yeah, your WhatsApp group. I'll be posting the couple of set of tests on tests online, but you can do on your own time, but you need to submit before the before the test. Okay. Really hope that one will help you in preparing the test one. I'm looking forward to see your work in your test one. So any question before we end? We have the meet the time 9:49 at the moment now. Class.
So doctor, for the
Yes.
each stroke must be 180 degree, even for 2-stroke and 4-stroke.
Yes, absolutely. Yes.
Okay, thank you, doctor.
Okay, there is, so you have what? You have what? One complete circle give you one stroke 180. Yeah, one stroke will give you half circle 180. The next stroke you give another the 80. So for two-stroke, you have 360. But obviously, you have only two type of engine, two-stroke and four-stroke engine. I will be also explaining to you how these four activities, yeah, typically on the induction, compression, power, and exhaust for two-stroke and four-stroke engine. And I also, inshallah, be touches about things like what happened when you have, incomplete combustion, where they provide you or they give you what you call it, the unfriendly to the environment, talking about carbon monoxide, typically, inshallah. Okay, I think we come to end. Really hope you enjoy my lecture. Seeing you again, inshallah, next weeks. Please study for preparation for your test and do your assignment. Thank you, class. I would like to end with Assalamualaikum warahmatullahi wabarakatuh, and also say that happy study, stay safe and stay healthy. Have a nice day and thank you.